Hello guys, welcome to the fourth session of Matrices. In this session, we are going to learn about matrix operations, namely addition, subtraction and multiplication of matrices. My name is Srinivas and I am one of the chief mentors of Career Launcher Bangalore. I am also an alumnus of IIM Indore and IIT Dhanbad. Right, so let's start with the basic matrix operations. There are three types of matrix operations we're going to look at. First two are addition and subtraction of matrices. And the second is going to be about multiplication of matrices. So let's first focus a little bit on the addition and subtraction of matrices. Now, for the matrices to be added or subtracted, one of the most important things to be kept in mind is only those matrices whose dimensions are same can be added. Only those matrices whose dimensions are same can be added. That is one of the prerequisites for the matrices to be added or subtracted. The reason is, when I explain to you how are they added, it becomes very obvious. When you're adding two matrices, let us say this is matrix A, this is matrix B. Effectively, you will add the corresponding terms or elements. That's all, right? So this becomes your A plus or minus B. So addition or subtraction, basically what happens is you will take the corresponding elements and then add or subtract based on what you want. And because the number of elements have to match, it means the dimensions have to be same, else you cannot add them, right? So that is the reason why the dimension should be same. It's very straightforward, addition or subtraction. The next thing we're going to see, a small point, is multiplication or division, but not of matrices. Here, first with a constant. We already saw this actually for a row or for a column in the matrix operations, right? But here it is the entire matrix, not just a row or a column. If you remember, when I wrote R1 as some A times R1, basically this row only is getting multiplied, right? Here it is not just a row. When I write a constant K multiply with a matrix like this, it means every element is getting multiplied in this with K, the constant K. That is what I have mentioned over here. When you multiply or divide a matrix with a constant, so constants are also called as scalars. Scalar is basically a single number. So when when matrices are getting multiplied or divided using a scalar, then every element gets multiplied or divided. That's all. So this matrix, it is not called matrix multiplication. Remember, this is called multiplication of a matrix by a constant or by a scalar. The next thing we're going to look at is called matrix multiplication, right? So what is this matrix multiplication? Matrix multiplication is multiplication of two matrices, a matrix A multiplied by a matrix B, right? So matrix multiplication, right? Now to do this matrix multiplication, one of the most important conditions that you have to keep in mind is the number of columns of the first matrix should be equal to the number of rows of the second matrix. Let me explain what I mean. If you have a matrix A of the dimensions 2 by 3, then you are multiplying with the matrix B. The dimensions of B should be 3 into something, anything can be there. But the point is, the columns here should be equal to the rows here. So these two should be same. It could be a 3 by 4 or a 3 by 2, whatever it is, doesn't matter. But the columns of the first and the rows of the second should be same. If they are not same, then multiplication is not possible. So I can have a 2 by 3 matrix, which I'll show as an example. Another example, just in terms of dimensions. If I write A into B, I can have a 1 by 3 matrix multiplied by a 3 by 2 matrix. So 1 by 3 is like this, 1 row, 3 columns. So you have A, B, C like this. And a 3 by 2 matrix is I, J, K, L and M, N. This is 3 by 2, 3 rows, 2 columns. And this is 1 row, 3 columns. These two can be multiplied. Right? Now the second property which you have to keep in mind is when you multiply. So when you have A and B, X rows, Y columns, obviously B should be Y rows and Z columns. When these two match, the result AB, the result matrix, let's call it as C. Let's call it as C. The C matrix, the dimensions of C is also known. It will be X into Z. So this row and this column will be coming to your final end matrix. What does it mean in terms of an example? If I have a matrix A in the form of 1 by 3 and a matrix B in the form of 3 by 2, the result will be a matrix C in the form of 1 by 2, because this column and this row, they will come to your matrix C. Right? So these are two properties, or not properties, actually two requirements or two things that are required when you're dealing with matrix multiplications. Now let us see, how do you calculate the matrix C itself? What is the process of multiplication? It's not as straightforward as addition or subtraction of matrices. So it's a little bit, now I will not say complicated, it's a little lengthy. So let us take this example. You have, first of all, a 2 by 3 matrix multiplied by a 3 by 3 matrix. Remember, it is possible because 3 is matching. And what will be the output? The output should be a 2 by 3 matrix. The output should be a 2 by 3 matrix. Let's keep this in mind. Let's go forward. The first step will be to take your first row, row 1, and multiply it with column 1. What is the meaning of multiplication of row 1 with column 1? It means this and this multiplication plus this and this multiplication plus this and this multiplication. Right? So I will just write the value for you. This is what will happen. If you notice, 1 and 6 are getting multiplied. The first element of first row, first element of first column. Similarly, second element of second row, second element of the column, first column, and third element of the first row and third element of first column. This will form one number. This will form one number. Once you do this, the next step will be, take again the first row. Now in the second matrix, go to the second column and do the same. What does it mean? It means you will multiply 1 with 9. 1 comes from here, 9 comes from here. Then 2 with a 0. So 2 comes, sorry, negative 2. Negative 2 comes from here, 0 is here, and 0 with a 7. Right? Then the third step, again, take the first row, go to the third column, and that will become your third element. Remember, the answer is supposed to be, what is the answer supposed to be? This is a 2 by 3 matrix. This is a 3 by 3 matrix. The answer is supposed to be a 2 by 3 matrix. 2 by 3, which means there are supposed to be 3 columns. If you notice, column number 1, column number 2, and column number 3. Right? So the first row of the answer matrix you got. So how are you getting this? Once again, you are multiplying with the first row and third column. 1 and negative 1, negative 2 and 5, 0 and 8. Right? Go forward. Then once we finish the row 1 with all the columns, row 1 of the first matrix you multiplied with all the columns, you will now shift to row 2. Then repeat the process again from the first column. Repeat the process again, which means now you have 4 multiplied by 6. Where is the 4? This is the 4. Where is the 6? This is the 6. 8 multiplied by 1. Negative 10 multiplied by 3. That becomes your second row, first element in your answer matrix. Similarly, do the other two also. I'm doing both of them at the same time now. Take the second row, second column, you'll get one answer, and third column, you'll get another answer. So the second row, so row 2 into column 2 is here. Row 2 into column 3 is here. This one is your row 2 into column 3. This is your row 2 into column 2. I did both of them in the same single step. So 4 into 9, where did you get this 4? 4 came from here and 9 came from here. 8 into 0. So this 8 into 0 here, you got it from 8 and 0. Similarly, negative 10 and 7. Negative 10 and 7. And in the likewise manner, you write the 4 and negative 1. This 4 again from the row 1 and negative 1 from column 3 and so on and so forth. So when you simplify this entire thing, if you notice, there are 3 columns and 2 rows. So what do you get? The final answer will be in this manner. And if you notice, this is a 2 rows, 3 columns matrix. 2 rows, 3 columns matrix. Right? This is the process for matrix multiplication. Right. Now, I understand that it looks a little bit cluttered. There are a lot of possibilities for you to make mistakes because you might get confused when you are multiplying. So there is a slightly better way. Actually, I will not call it as a different way, but I would call it as a better representation of how to multiply things. And this usually, students don't make mistakes if you follow this. The method here, or the idea here, is write an x-axis and a y-axis, or just put a horizontal line and a vertical line. In the vertical line, write your first row and the second row. So if you notice, this is your first row, written here. This is your second row, written here. Similarly, write your columns here. Now, not rows, remember, these are columns, 6, 1, 3 column. It's always row by column multiplication, column and column. If you write it this way, it might take you 5 extra seconds to write, but the chances of you making mistakes will decrease by a lot. Right? So it's worth doing it in the exam also. You can waste that 5 seconds, 6 seconds extra in writing this. Now, what are you supposed to do after this? That becomes easy. Now you take the multiplication of these two. Here the multiplication looks easier for you. What happens? 1 into 6 minus 2 into 1, 0 into 3. So the orientation of row versus column is gone. You are now looking at row versus row kind of a multiplication. It's not that difficult here. It's easy for you to remember this. Then the next 2 will come here. The next 2 will come here. So it's effectively the same thing that you're doing, nothing different. I'm not saying it's a shortcut. It is not at all a shortcut. The point is, instead of doing it in a cluttered way where you have to remember a row and a column, here if you represent it in a slightly different way, the confusion will be gone and significantly decreases the chance of you making an error. So I strongly recommend that you follow this method of, or this visualization of multiplication. You will still get the same answer. There will obviously not be any change. Right? So that's all today or in this class regarding matrix multiplication, addition, subtraction, and multiplication of matrices with a constant. Thank you guys. Have a good night or a good day, depending upon when you're watching it.